Alright, here we're going to take a look at 3 different examples using similar triangles and finding some side lengths, or in this case, just figuring out which triangles are actually similar. Now the first thing that I'm going to notice in this picture is I have a pair of parallel lines. And this brings me back to what I learned about parallel lines that were cut by a transversal. So the first thing that I'm going to look at is if lines are parallel and cut by a transversal, and I'm going to use the red and the green here as my transversal, then I know that the alternate interior angles are going to be congruent. And I have a pair of alternate interior angles here and here. And then I can also go back and use those same 2 lines here, say that, well, they're actually segments, say they're parallel, because they are, and then I'm going to use the pink and blue as the transversal. Well, if that's the case, then the alternate interior angles are congruent, and that would be here and here. And then I can come back and I can say, well, I see a pair of vertical angles right here and here. And really I didn't even need that, because I could use the single arc and double arc from this triangle over here on the left, and the single arc and the double arc from the triangle on the right, and I could say that those 2 triangles are congruent. That would be triangle, what do we have? Triangle ABE is similar to triangle. Now I got to make sure that I get this matched up right. Vertex A is going to match up with vertex C, and then vertex B is going to match up with vertex D, and then the 2 E's match up. So those 2 triangles are similar, and I used the AA similarity to prove that those 2 triangles are congruent. I actually went AAA, but we don't need the third A. I could have also used the fact that I know corresponding sides. I could have looked at ratios. Could have done 21 over 35 and 27 over 45. And I'd find that those 2 ratios are equal, meaning the sides are proportional, and then I have those vertical angles being congruent. I could have used the SAS similarity to prove that those 2 triangles are similar as well. Now my next example, now I want to find the value of x. But before I do that, I see that I have 2 triangles, and really it'd be nice if I knew that they were similar. So in this one, I go back and I'm just going to start here, and I see a pair of vertical angles. Something I'd recommend you look for all the time. If you can find them, real easy to know that they're congruent. And then I'm going to go back to my parallel lines. I see I have a pair of parallel lines in the red. Well, if lines are parallel and cut by a transversal, and I'm going to use this as my transversal, then I know alternate interior angles are congruent. That would put me here and here. Now I see my 2 triangles. I have 2 angles congruent to 2 angles in another triangle. Using my AA similarity, I know the triangles are similar. And if the triangles are similar, then I know the sides are proportional. So now I can write my proportion. And I'm just going to start here with my proportion, and I'll start filling in numbers. I'm going to start with the 10. The 10 is going to correspond to the 4 in the other triangle. So there I have a ratio of corresponding sides. Well, now being I started with the triangle on the left, finding a side length, my next numbers or variables are going to have to come from that triangle on the left. I'm going to use the 2x plus 10, and that's going to correspond to the x plus 3. And the way I figure out how they correspond, like the 10, that's the side that's between the double arc and then the no arc. So I come over to the other triangle and go double arc and no arc, the 4's there. The 2x plus 10, well, that was between the double arc and the single arc, so the x plus 3 has to be between the double arc and the single arc as well. Now I have an equation or a proportion that I can solve. I'm going to go ahead and do that. Cross multiply this way. I'm going to get 8x plus 40 equal to, and when I cross multiply this way, I'm going to get 10x plus 30. Continue solving my proportion. I'm going to subtract the 8x from both sides, and I'm going to subtract the 30 from both sides, all in this one step. So now I'm left with 10 equal to 2x. Finish this out by dividing by 2, and we just found out that x equals 5. Now, I'm a person that always believes we should answer the question. I'm going to come back up here and go, well, it asks us to find x, calculate the value of x. I did. we're done. Sometimes it may ask you to actually find missing side lengths, well then just plug that value of x back in. And my last example here is I want to know how tall this building is. And what I'm using here is, some people will wonder what's going on, but I have a person here that's 6 feet tall, and then this little thing that's on the ground is a shadow. That's supposed to represent the shadow of the person. The shadow right now is 4 feet tall. I look over here, I have a building that I don't know how tall it is. I can't scale the building and throw my tape measure down to figure out how tall it is, but I do know that I could measure on the ground the shadow, and the shadow's 55 feet. So I want to know how tall this building is. Well, what we have to realize is at any point in time during the day, the sun's going to shine down. So if I'm looking at a sun ray here, it's going to go from that top of that building down to the shadow, and it's going to create an angle right here. Same thing's going to happen here. That sun ray is going to come down from the top of the person there, and it's going to create an angle. Now, let me just kind of draw in the rest of this. If I were to draw there, I have a triangle. So I get this angle right here that's going to be congruent to this one up here. And they're congruent because as long as we measure these shadows at the same time during the day, that the angle that the sun is at is going to be the same or congruent. But then I look at, I only have one pair of congruent angles in these two triangles. I'd also have the right angle. I'm going to go with this assumption that that building was built perpendicular to the ground, and I'm going to go with the assumption that this person is standing perpendicular to the ground. So now I have those two angles. Using AA, it tells me that the two triangles are similar. Well, if they're similar, then I should be able to find missing sides. And now I can just start with my question mark of, well, how tall is the building? Over, well, now I'm going to go to the height of the person, because those would be the corresponding sides of my two triangles. My other ratio, I'm going to have to go to the building. This is going to be the shadow in the building, and then over the shadow of the person. Solve my proportion here. So 6 times 55 is going to put us at 330, equal to 4x. Do a little division here on both sides. We find out that x equals 82.5, which tells us then that the height of this building is 82.5 feet. I can measure that, or I can find the height of that without actually measuring it. Then that's going to conclude the example parts of the similar triangles.